Before we discuss our research, let me introduce myself. My name is Faisa Maulidina, and the other authors we can see from this slide. Next, here's the outline that we will discuss today. First, there's introduction, material and methods, results and discussion, and lastly, the conclusion. First of all, we must know what is diabetes. Diabetes is a disease that occurs when the blood glucose level is higher than normal. This is due to the inability of the body to release insulin, which is a hormone that produced by the pancreas effectively. The number of these diabetes cases has been increasing each year. Despite its huge impact, there is currently no cure, but it can be prevented and managed. Therefore, it is important to classify the number of individuals with this disease. In the medical field, classification is used to classify a patient's illness, which make it easier for doctors to give an accurate therapeutic solution. Therefore, several methods in data mining, such as decision tree, neural network, and supervector machine have been applied as classifiers. Therefore, to classify this diabetes dataset, SVM method was used. The backward elimination selection feature was also included in this study to select all the relevant features in order to obtain a higher accuracy. Now, let's move on to the material. The dataset consisted of 768 instances with 8 features and subclass with 268 diabetic and 500 non-diabetic patients. So, from this table, we can see all of the features that included in this diabetes dataset. These are the steps of backward elimination selection feature. Firstly, all the features are to be tested in a regression model with a significance level of 0.05. When the p-value of a feature is greater than the significance level, it will be eliminated. Step 2 will be repeated until all the features become significant. If it's all done, the model will be fitted with the new set of features. Now, we will talk about supervector machine. The SVM concept is useful in finding the best hyperplane that plays the role of a separator between two classes. Figure A draws several patterns which are members, positive and negative class. The concept of SVM is to find a hyperplane that separates datasets into two classes. The existing data is denoted by this, while its label is denoted by this. Assuming that class -1 and +1 can be separated by a hyperplane without dimensions, which is determined by equation 1. A pattern xi that belongs to class -1 is defined by equation 2, while pattern xi which belongs to class +1 is defined by equation 3. The maximum margin was found by maximizing the value of the distance between the hyperplane and its closest point. From finding the minimum point of equation 4 and noting the constraints of equation 5, a quadratic programming problem was formulated. This problem can be solved by several computational techniques, such as Lagrange multipliers as shown in equation 6. It was modified as the maximization of problems that only contain alpha I by considering the optimal point gradient L equals to 0 as shown in equation 7. Next slide. From this calculation, alpha I that obtained was mostly positive. This positive correlated data with alpha I is called supervector. To measure the accuracy, the data was classified using SVM. Furthermore, the model with the training process and accuracy was calculated using the confusion matrix, which is seen in table down below. We can see from this table there are only 5 features left. The 3 of them before were already eliminated by backward elimination method using p-value. The diabetes dataset consisted of 768 instances, 8 features with subclass. From the results, the significant features were obtained based on the p-value of the variables as shown in table below. The accuracy obtained by using 10% until 90% of the data training is shown in this table. From the results, it was seen that the highest accuracy obtained when using 90% of the data training, which is 85.71%, while the lowest accuracy value obtained when using 10% of the training data, which is 76.44%. Meanwhile, for SVM without using a feature selection, the highest accuracy obtained when using 90% of the data training, which is 84.41%, while the lowest accuracy obtained when using 20% of the data training, which is 75.77%. Comparisons were made to discover the better method between SVM with and without the backward elimination selection feature. So, it can be concluded that a higher accuracy was obtained when SVM with backward elimination was used, which was 85.71%. We can see from this table. Finally, we can jump into the conclusion. In this study, backward elimination for feature selection and SVM method for classifying the model was used to obtain the best accuracy value. Backward elimination was used to select the significant features for the model based on the p-value from each feature. The accuracy for the SVM algorithm was 84.41%, while the backward elimination accuracy value with the SVM algorithm was 85.71%. So, it can be concluded that the backward elimination method with the SVM algorithm had a higher accuracy value compared to using only the SVM method. For upcoming studies, the use of another method for this dataset is recommended for a better performance. From this proposed study, it is expected that this result is better compared to other methods and will benefit the medical field. Thank you for your attention.
Thanks for the presentation. Is there a question for Ms. Faisal from other presenters?
Oh, kelas 5 Pak Sahab jalan ini.
Is there any question from other presenters for Ms. Faisal? We have 5 minutes for question and answer session.
Hello, Mr. Lutfi.
Yes.
I want to ask if we want to ask the presenter, we must submit in the link at the chat, or we can only unmute and ask the presenter.
You can ask to the presenter directly, or if you want to write your question using the link, it is also allowed. So you can choose whatever you want. Or maybe Shahrul, is there any question in the link?
Yeah, link question in the box chat. You can fill a question in the box chat, the link in the box chat. Thank you.
Yes. Is there any question submitted to that link? Shahrul?
Okay, Mr. Lutfi, I want to ask directly for Faisa Maulidina. Okay, hello Faisa. Thank you for your presentation. I want to ask one question. My question is, why did you choose backward elimination for selection feature? Thank you.
Okay, thank you for the question. So, first of all, we must know that backward elimination is a feature selection method that used to remove the irrelevant features based on the linear regression model. So, why did I choose this method? Because this method has some advantages, including increasing training time, decreasing complexity, and improving performance and accuracy. So the SVM method in this diabetes dataset will be improved. That's my answer.
Okay, thank you, Faisa.
You're welcome.
Thank you, Faisa, for the first presentation. We will continue to the next presenters. The second presenter is Ms. Valerie Virginia Putri, and her title of paper is Ovarian Cancer Classification using K nearest neighbor and support vector machine. Time is yours, Ms. Valerie.
Okay, hello everyone. I will play my presentation video right now. Sorry, but I can share my screen.
Wait a minute.
Okay.
I have made you a co-host now.
Okay.
You can start your video. Don't mute your voice.
What? Sorry?
You can start your video.
I have started it, but it didn't show it.
We can see it, but it don't have started.
Oh, wait.
Hello everyone. In this opportunity, we would like to present our study about machine learning implementation in the medical field. The title of our study is Ovarian Cancer Classification using K-nearest neighbor and support vector machine. Before we begin, let me introduce the authors. The first author is Valerie Virginia Putri Wibowo. The second author is Zuherman Rustam. The third author is Sri Hartini. The fourth author is Faisa Maulidina. The fifth author is Ilsya Wirasati. And the sixth author is Wismaji Sadewo. This presentation is divided into 4 parts. The first part is introduction, second part is materials and methods, the third part is result and discussion, and the final part is conclusion. First, we will begin with introduction. Cancer is a deadly disease and a major cause of global mortality among women. The number of women population in the world is about 49.5%. Ovarian cancer is one of the most common and the deadliest of all gynecologic cancers. The approximated annual occurrence is 225,000 cases with 140,000 deaths worldwide. Ovarian cancer occurs when cells grow abnormally in the ovary and become a tumor. What is the ovary? The ovary is a reproductive gland in women that produces egg cell, progesterone, and estrogen hormone. The ovary with cancer looks swollen and has a tumor that develops. The risk factors of this condition are genetic, nulliparous women, the use of hormone replacement therapy, have had breast cancer, obesity, lifestyle such as smoking and diet, and age. Most women with this condition are those who are above 63 years old. The symptoms of ovarian cancer are non-specific, such as weight loss, changing bowel habit, feeling full early, bloating and massive swelling of the abdomen, indigestion, and pelvic and abdominal pain. However, most of the patients do not show those symptoms even at a late stage, therefore, early diagnosis is difficult. These are the stages of ovarian cancer. More than 70% of women with ovarian cancer are diagnosed at an advanced stage, but only less than 40% have a survival rate of 5 years. Since timely detectation is related to increased survival rate, early diagnosis is very important because it has significant impact on the fatality level. In the medical field, machine learning can be implemented for analyzing patient data and diagnosing diseases. The machine takes the important features of the patient as input and produces an accurate diagnosis as output. There are many machine learning methods that are used in classification. Among those methods, support vector machine and k-nearest neighbor are frequently used due to their good performance. Therefore, the study proposed k-nearest neighbor and support vector machine methods to classify ovarian cancer and find which one has better results. And we have to look to the second part, materials and methods. Dataset. Ovarian cancer dataset obtained from Al Islam Hospital Bandung consisting of 203 instances. There are 5 attributes which are cancer antigen or tumor marker, hemoglobin, leukocytes, hematocrit, and platelets. And the target attribute with 1 refers to instance with ovarian cancer and 0 refers to healthy instance. Now the method. We use supervised learning as a machine learning task to classify ovarian cancer. It works by learning the relationship between attributes in the training dataset and using the result to build a model that predicts unlabeled data. The first supervised learning method is k-nearest neighbor. The idea is to determine the class label of new sample based on its similarity to all samples in the labeled instance. The steps of KNN algorithm. 1. Set the number of k as the parameter. 2. Calculate the distance of a new sample to all samples in the training data. 3. Select k-neighbors in the training data which have the nearest distance to a new sample. 4. Use the most votes of class label from k-nearest neighbors as the label of new sample. This is picture that illustrated KNN. There are 3 class labels, omega 1, omega 2, omega 3. There is a sample XU with K5 that classified by KNN as part of omega 1 because XU has more neighbors in omega 1 than in omega 3. The class label of new sample is determined based on their similarities by measuring the closest distance between samples. We use the Euclidean distance with the formula as follows. The second method is a perfector machine. The idea is to build an optimal hyperplane for splitting data by measuring the maximum margin. In nonlinear problem, SVM map the input vectors or samples into a higher dimensional space using the kernel function. This is an illustration of SVM. There are 2 classes which are positive and negative. The idea is to create an optimal hyperplane that separates the data classes with W is weight or orthogonal vector, B is the bias or distance between the origin and the hyperplane, and X is feature vector. The optimization problem of SVM is written as follows. To solve the optimization problem, Lagrange function is applied. Then the optimization problem becomes for A positive where A is Lagrange multiplier. The decision function of SVM is For non-separable cases, the select variable and parameter C are added to the optimization problem. Therefore, the optimization problem is kernel function can be applied when the classes are not linearly separable, with the formula is written as follows. V is a function that used to map input vector x into higher dimension. The study used the RBF kernel with the formula shown as follows, with gamma as its parameter. Confusion matrix. The confusion matrix is used to measure the performance of machine learning methods. The method performance can be evaluated by calculating the accuracy, recall, precision, and F1 score. True positive is the number of ovarian cancer instances that were correctly predicted. False negative is the number of ovarian cancer instances that were incorrectly predicted. True negative, the number of non-ovarian instances that were correctly predicted. And false positive is the number of non-ovarian instances that were correctly predicted. Let us now turn to the results and discussion. The training data that used was ranged from 10 to 90%. The parameter are k equals 7 for k and n, c equals 1000, and gamma equals 0.1 for SVM with RBF kernel. The results of k and n. We can see that the k&n method produced higher results of 90% of training data with 90.47% of accuracy and 94.11% of recall, precision, and F1 score. The recall values was higher than the precision values. This implies that the false positive was higher than the false negative. Next is the results of SVM. SVM also produced higher results using 90% of training data with 90.47% of accuracy and 92.30% of recall, precision, and F1 score. The precision values was higher than the recall values. This implies that the false negative was higher than the false positive. Based on the results, both methods produced the same value of their highest accuracy. However, the F1 score value of k and n was higher than SVM. Based on our findings, a high value of F1 score shows a high performance of classification. Therefore, k&n is a better method than SVM to classify ovarian cancer. This leads to the final part, which is conclusion. In conclusion, let me sum up the main points. The study applied k&n and SVM with RBF kernel as supervised machine learning methods and compared them to classify ovarian cancer. The k&n idea was to determine a class level of new sample based on the majority class by measuring the closest distance. Meanwhile, SVM is to obtain an optimal hyperplane that separates the data into classes by measuring the maximum margin. For results, k&n produced higher results than SVM and is a better method to classify ovarian cancer. The study is hoped to be a reference for doctors when making diagnosis. For future research, a larger dataset is recommended to use to get better results. And here's the references of our study. Thank you very much for your attention.
Thanks for the presentation. Is there any question from other participant or Ms. Valerie? Is there any question for Ms. Valerie? Shahrul? Is there any question?
Nothing, bro. Nothing further.
Okay, maybe I will ask one question for Ms. Valerie. In your research, you use two methods. The first one is k&n and the second one is SVM. Do you use other methods? The other methods, the other from k&n or SVM?
Okay, thank you for the question, Mr. Lutfi. Yes, we can use the other method, the other machine learning method for this cancer, ovarian cancer, but here in this paper, I use KNN and SVM because SVM and KNN have been implemented in previous studies and produce good results. So I choose these methods to classify ovarian cancer, but the other methods can be implemented too.
Okay, so you choose those methods because it has been used in past for ovarian cancer or also for other cancer.
Yeah, for other diseases.
Okay, I think it's enough for Miss Valerie. We continue to the third presenter. The author is Miss Filza Zafarina, and the title is Comparison of Colorectal Cancer Classification between K nearest neighbors, KNN, and neural network. For Ms. Filza Zafarina, time is yours.
Okay, thank you for your opportunity. Okay. Can you see my screen?
Yes, I can see it.
Okay. Hello everyone, my name is Filza Zafarina. I will present about
I'm sorry, I cannot hear the voice from
Sorry?
your video. I
Sorry?
cannot hear your. I cannot hear the voice from the video.
Wait. Outline for presentation. Can you hear?
Yes.
Okay. Hello everyone, my name is Filza Zafarina. I will present about comparison of colorectal cancer classification between K nearest neighbors, KNN, and neural network. My team is Zuherman Rustam, Yasirli Amelia, Ilsha Wirasati. We are from Department of Mathematics, University of Indonesia. This is my outline for presentation. The first is introduction, and then material, next is our method, and then result, and the last is conclusion. Introduction. Cancer is a disease that causes death in second place in the world. Detecting these diseases when still at an early stage is associated with markedly improved survival prospects. Cancer is a disease that can be detected by machine learning. It can be seen from the development of data mining in medical science is increasing rapidly. This increase can be seen from the high prediction results, which can reduce treatment costs, increase the chance of recovery of patients, and decision to save lives. Colorectal cancer is cancer with third death rate, responsibility for around 60,000 per year worldwide. Various methods can be used to cure this disease, including system, chemotherapy, radiotherapy, and resection surgery. However, there is no efficient treatment for colorectal cancer patients, especially in patients with liver metastasis or CRLM. CRLM are the main causes death in this disease. The treatment commonly used in CRLM are chemotherapy and liver resection. However, its toxicity and side effects limit the use of this chemotherapy. There are some methods of previous research for processing colorectal cancer datasets, such as neural network, fuzzy semen, and random forest. This research used another method for classifying the data, which is k-nearest network and neural network. Therefore, this method will help the medical staff to classify the medical problem easily. Material. This research using Jupyter Notebook as software for running the program KNN with different k-values and neural network classification. The program language used for the paper is Python 3. The colorectal cancer dataset was taken from Al-Islam Hospital Bandung, Indonesia. This dataset consists of Begin set 163 and malignant cases 47. The colorectal cancer dataset consists of 6 variables as shown in Table 1. For classification, this research used KNN with different k-value and neural network for classification, and then the method evaluation using 45 random states. The last is software and language using Jupyter Notebook as software and Python 3 for the language. Table 2 is sample of colorectal cancer dataset for Al-Islam Hospital Bandung, Indonesia. Method. The first method is KNN. The closest KNN is well-known non-parametric classifier that is widely used in the pattern recognition. KNN is method to classify a space object data by calculating the value of detectivity based on the distance function and the pattern of similarity to certain objects. KNN is used to determining class membership with the highest environment value. In this method, there are several formulas for calculating distance, one of which is Euclidean distance. This is the formula and information about Euclidean distance. The second method is neural network. Neural networks are machine learning which is used widely in many application areas. This is due to their higher classification performance. This algorithm uses a universal function approach that can model linear and non-linear data. A type of neural network, a simple three-layer feed-forward network with well-established generalization properties, is called a multi-layer perceptron. The classification process uses a neural network, which is entering data into the classifier to the input layer to produce output in the hidden layer. This is the formula for input layer, and this is the formula for classification at output layer. The last is the hidden layer, and the output layer use the tan sigmoid and soft activation function. This is the formula for the tan sigmoid function, and this is the formula for the soft function. Backpropagation learning algorithms are used to train neural networks. This is done by updating the wave backward from the output layer to the hidden layer to the input layer by spanning the difference between the desired output and the prediction output. Can be seen in this equation. Computation matrix. One of the methods used to calculate accuracy in the concept of data mining or decision support system. Accuracy is the ratio of true prediction in the whole data. This is the formula for accuracy. And then this is the information about our computation matrix. Result. This research using Jupyter Notebook as software for running the program KNN and neural network. In the processing colorectal cancer classification problem, in this test, the number of data training is equal to 10% to 20% until 90%. This is the result of colorectal cancer classification using KNN. We use K equal 1, and then K equal 5, K equal 7, K equal 9, and K equal 11. Next is Table 5, the result of colorectal cancer classification using neural network. Conclusion. Colorectal cancer detection quickly is very important. It is useful for finding cancer quickly before being infected to all organs of the body. However, this is difficult because colorectal cancer has no specific symptoms. The KNN and neural network methods can help detect colorectal cancer based on blood tests and eggs. Thus, the final result indicates with better performance for KNN accuracy is 0.786 in K parameter equal to 7, 9, and 11 has the same accuracy with 60% data training, and the neural network reached 0.904 with 90% of data training. This is our
Thanks for the presentation from Ms. Zafarina. Is there any question from other presenters?
Yes, I have a question for Filza Safarina.
Okay.
For Filza Safarina, I want to ask about as you said in your presentation, you use the tan sigmoid as your activation function. What's the reason what's the reason you use that function? Thank you.
Okay, you can answer it, Ms. Farina.
Okay, thank you for your question, Sabrina. I use tan sigmoid function for because there is hidden layer and output layer that use a tan sigmoid function from my PPT.
Okay, thank you for your answer, Filza.
You're welcome.
Okay, I also want to ask a question. In your paper, you use KNN and neural network. But I know that neural network, there are many types of neural networks. So maybe you can explain to us what type of neural network you use, or it is just a multi-layer perceptron or feed-forward neural network, or what type do you use?
I use artificial neural
Artificial.
network. Yes, sorry.
Okay, because I know many type of artificial neural network, so I think the best method you must write in your paper is not neural network, but uh, I think it is like multi-layer perceptron.
Okay, I will check it later. Thank you for your.
Okay, it is the third presentation in this parallel session. We will continue to the fourth one. The author of the fourth paper is Ms. Indah Kalu Shafira, and her title is Application of Density-Based Spatial Clustering of Application with Noise to Optimize Matching Problems in Ride-Sharing for Maximized Total Distance Proximity Index. For Ms. Shafira, time is yours.
Okay, thank you for the opportunity. I'm going to share my screen now. I can share.
You can try it now.
Okay.
I'm sorry, I cannot hear the voice.
Oh, okay, sorry.
Hello everyone, today I'm going
Is it okay now?
Okay, I can hear it.
presenting our research with title Application of Density-Based Spatial Clustering of Application with Noise to Optimize Matching Problem in Ride Sharing for Maximize Total Distance Proximity Index. Me, Indah Galuh Shafira, as the author one, will be presenting today. The outline for presentation is introduction, literature review, model and method, experimental result, and conclusion. Jakarta is the nation's capital of Indonesia. With this high mobility of people and commodities in the city, the transportation needs are urgently needed. According to Badan Pusat Statistik, the high mobility of people and commodities, followed by the lack availability of safe and comfortable public transportation, causes the use of private transportation grow rapidly every year. The last 5 years, average annual growth of motorized vehicles was about 9.5%, while the average annual growth of road length was only about 0.01%. The rapid growth of private transportation and low growth of road construction are the causes of traffic congestion. Many ways to solve traffic congestion problems. For example, to increase the amount of public transportation, but for the smaller scale, ride-sharing might be the solution to reduce the private car ownership. The problem encountered in this system is to get the optimal driver-rider pair, which is the matching problem. The purpose of matching problem is to identify suitable matches between passengers requesting ride-sharing services with relevant drivers available. Since we got the huge amount of participants are involved in this system, but the optimization time is very short, we propose a method to reduce the driver-rider pairs that are possible to do ride-sharing by clustering. The clustering is based from the location of origins and destination both drivers and riders. So based on the illustration, we'll only calculate 8 pairs instead of 16 since driver 1 is not in the same cluster with rider 3 or 4. The purpose of optimizing the matching between driver and rider that are considered in this paper is to maximize the total distance proximity index or DP index. The optimization problem to get the driver-rider match can be represented by maximum weight in bipartite graph. The Hungarian algorithm will be used to solve the determination of the driver-rider pair by DP index as the weight function. The basic idea of the DP index is if the driver and rider which are in a close proximity and have the similar distance from its origin to destination, then the driver-rider pair will be a good match. Now we move to literature review. The first one that will be discussed is ride-sharing. Ride-sharing is a model of transportation in which at least 2 ride-sharing participants share vehicle for a trip and split travel costs with others that may have similar itineraries and time schedule. There are 4 types of ride-sharing based on the numbers of participants. The type that will be used in this paper is single driver and single rider. Ride-sharing involves at least 2 sets of participants, set of drivers, and set of riders. For each participant, A is element of D union R are assumed to be known the origin participant, the destination participant, time announcement, earliest departure, travel distance, and travel time, and the latest time the participant can arrive at its destination or latest arrival. In latest arrival, we calculate it by adding 40% of total travel time to ensure both participants by doing ride sharing will only add the travel time by 40% of the participants' total travel time without doing ride sharing. And the last one is the time window of each participant. The next one is DB scan. The basic idea of DB scan is to distinguish points from dataset into clusters or groups based on the dense adjacent region within the total data space, then separate it into different clusters by contiguous areas of lessened density. DB scan need 2 parameters that are epsilon and minimum points. Some terminologies that are commonly used in DB-scan are the first one is border point, core point, and noise. Based on the definition in the illustration, the blue point is core point because it has 5 points on its epsilon neighborhood. The green point only got 3 points on its epsilon neighborhood, so it is considered as border point. And the gray one is far from core point and only got 3 points on its epsilon neighborhood, so it's called noise. Next one is reachability. Based on the definition, in the illustration, point Q is directly density reachable from P. Next is density reachable. Based on the definition, Q is not a core point, then Q n minus 1 is not directly density reachable from P, then P is not density reachable from Q. The next is density connectivity. Based on the definition in the illustration, Q is density connected with P, then P is density connected with Q. Now we move to model and method. This paper presents a pre-processing method to reduce driver-rider pair that will be optimized based on their location and time feasibility. The first one is possible match is based from the location from participants' origin and destination. A driver-rider pair is considered as possible match if both the driver and rider fulfill these following conditions. The first one is the origin of both driver and rider are belong in the same cluster, and the destination of both driver and rider are belong in the same cluster. After we obtain the sets of possible match, we will determine if the driver-rider pair that are possible match is feasible by time or not. To be considered as feasible match, the time window between driver and rider must be overlapped. Also, the driver-rider pair considered as feasible match if the pair meets 2 conditions. These are the delta TD must be greater than 0 and the delta TR must be greater than 0. We move to model formulation. We first take a look on the definition of DP index is the minimum ratio between travel distance from driver's origin to driver's destination and travel distance from the rider's origin to rider's destination. So the mathematical model is shown in the slide. Equation 1 describes the objective function is to maximize the sum of DP index. Equation 2 and 3 assure that the set of riders and drivers that are considered as feasible match are counted in only one optimal solution. Equation 4 is a binary variable that is equal to 1 if driver-rider pair is matched, 0 if driver-rider pair is not matched. The next is illustration. The data used in this paper consists of latitude and longitude of both origin and destination from each participant, latest arrival, time announcement, and earliest departure. The next step is to cluster latitude and longitude of both origin and destination from each participant. We got 4 clusters with noise that is origin of driver 4, which means driver 4 will not match with any riders. By the possible match algorithm, we obtain the set of possible match are the driver 1 with rider 1, driver 1 with rider 4, driver 2 with rider 2, driver 3 with rider 3. After we obtain the possible matches, the time feasibility and delta S condition must be checked. The results show us that the driver 1 and rider 4 got the negative value of the delta TD and the delta TR, and also the KD or latest time driver must pick up rider is earlier than the earliest departure of driver 1. So driver 1 and rider 4 won't be matched. The result of feasible matches can be represented by maximum weighted in bipartite graph. Based from Hungarian algorithm with DP index as the wake function, we got driver 1 and rider 1, driver 2 with rider 2, and driver 3 with rider 3. We will compare the result with clustering and without clustering. Without clustering, using the same example data, we match all the possible driver-rider pairs. So we got 16 possible match of driver-rider pair. By this 16 driver-rider pair, we will check the time feasibility and delta S condition. The result shows that we got the same result with using clustering method. The experimental data used in this paper consists of 120 coordinates. These coordinates consist of 30 coordinates of drivers' origin and destination and 30 coordinates of riders' origin and destination. The total time period in this paper is 3 time periods with 50 seconds as the time steps. The first time period consists of drivers and riders with time announcement in interval 7 o'clock 1 second until 7 o'clock 50 seconds and so on. We will check the result for without clustering method. Without clustering, we got total final matches are 21 driver-rider pair with the total DP index is approximately 14.9. With clustering method, we got total final match are 22 driver-rider pair with the total DP index is approximately 15.2. Therefore, the results of 3 periods show that DB-scan clustering method can solve matching problem in ride-sharing better than without clustering. The lesson is conclusion. We propose a method to reduce the calculation of possible match in matching problem in ride-sharing by using DB-scan. Based on the experimental result, we can conclude that with DB-scan clustering, we obtain more match pairs of driver-rider and total maximum DP index.
Okay, thanks for the presentation. Is there any question for Ms. Shafira from ICoMPAC Center? Shahrul, is there any question in the link in the Google Form?
Nothing question, bro. Nothing question.
Nothing. From other presenters, is there any question for Ms. Shafira?
I want to ask a question for Indah Galuh Shafira.
Okay.
Okay. In your paper, you explain about the clustering method. So I want to ask for you, is it it is can your method be grouped as a machine learning method?
Oh, yes, since it is a clustering method and it is classified as unsupervised learning, so it is considered as a machine learning method. Thank you for the question.
Okay, thank you for your answer.
Thanks for the question. Is there any other question? If there is no question, we will continue to the next presenter. The next presenter is Ms. Anggun Septiani, and her title of the paper is Application of Agglomerated Hierarchical Clustering to Optimize Matching Problems in Ride Sharing for Maximize Total Distance Settings. For Ms. Anggun Septiani, time is yours.
Okay, thanks for the chance, Mr. Shahab. I'm going to show my video. Sorry. Sorry, do you hear the sound of the video?
Not yet. I cannot see your video.
Oh, sorry.
You can use the share screen.
Oh, I forget. Do you hear my voice?
Not yet. I see your folder, but I cannot see your video. I just see your folder.
Oh, sorry.
Maybe you can first close your share screen, and then you click the share screen again on your video, not on your folder.
Okay. Do you see my video?
Yes, I can see.
Okay. Do you hear the voice?
I think the voice is too small.
This is the maximum.
Maximum volume.
Yes, maximum.
The participants can hear the voice.
I'm sorry, Anggun.
Yeah.
You may check the point share the audio first before you screen the video. Close the share screen first, then check the share audio.
Is it okay now?
Play.
You may.
I'm sorry, I cannot hear it. Maybe Shahrul, can you play the video for her?
Yeah, I can help you.
Yeah,
Wait.
I'm sorry for the trouble.
Yeah, wait.
The number of the paper is 27. Video 27.
Hello everyone, my name is Anggun. Today I would like to
I don't see the video.
present our research with the title Application of Agglomerative
Share screen the video, Shahrul.
Problems.
I only see your folder, not video.
In ride sharing for maximize total distance savings.
Okay, it's okay now.
On the first part, we will discuss about traffic jam, includes its causes, effects, its alternative approaches, and the reason why we have to apply a ride sharing model. On the next part, we are going to talk about ride sharing and agglomerative hierarchical clustering. On the third part, we will discuss about matching problem model, definition of distance savings, and process of determining match that will do ride sharing trip. For the next part, we have the result of our experiment, and the last part is conclusion. Between 2000 and 2018, the number of vehicles in Indonesia has increased. Based on data from the Statistics Center of Indonesia, the average growth rate of the number of vehicles is 13% per year. According to our source, the growth in demand for transportation, which is in line with the increase in the number of vehicles that are not proportional to road capacity, is the cause of traffic jam. In addition, the low occupancy rate is a significant cause of traffic jam. Traffic jam is the cause of the increasing fuel consumption and air pollution. Basically, there are two traffic jam causes. There are disproportion between the number of vehicles and road capacity and the low occupancy rate. One of the alternative approaches to reduce traffic jam is to increase road infrastructure development. But according to Shafruddin, his research says that road infrastructure development tends to encourage high levels of inefficient usage of private vehicles. Another alternative approach to overcome this problem is to increase the occupancy rate of vehicles by applying the ride-sharing driving model. Generally, ride-sharing is defined as a ride-sharing model that aims to bring travelers with similar location and travel time simultaneously, thereby saving mileage. There are some reasons why we have to use ride-sharing model in our transportation system. First, it can reduce private car ownership. Second, it allows the participants to split the cost of the travel. And the last, it's environmentally friendly. However, there are obstacles on implementing ride-sharing. The problem is to find the optimal participants pair to obtain the maximum total distance savings. It's name matching problem. We have two sets of participants. First, for they who want to share a trip, we call it driver, and for they who need a ride, we call it rider. The search for the optimal driver and rider pair is constrained by the high level of requests for ride sharing from participants, which must be served in very short optimization time. An alternative approach in dealing with the constraint is to cluster the origin and destination points of each participant. According to Ape and Gabri's research on 2006, clustering is an alternative technique that promises to reduce the burden of recording all comparison in the matching process. For this reason, we propose a clustering using the agglomerative hierarchical clustering method, or AHC, with the aim of classifying participants' location from the ride-sharing system. The use of AHC aims to obtain a set of possible matches that will be checked for time feasible constraint and distance savings. The optimization in this matching problem aims to find the optimal combination of driver-rider pairs to take a ride-sharing trip that results the maximum total distance savings. The match that will do ride-sharing trip is selected by using the Hungarian algorithm. Based on its management, ride-sharing is divided into two, organized ride-sharing and unorganized ride-sharing. Organized ride-sharing is operated by the organizer, which provide ride matching opportunities for participants who have never met each other. The manager is matching against this. On this research, the type of ride, you can see the other type of ride-sharing on table 1. On this research, the type of ride-sharing that will be discussed is single driver, single rider that have a problem on matching driver and the rider. AHC is a clustering method that merges two objects or clusters into one cluster recursively so that one big cluster remains. We have two parameters that are used to measure the proximity between two objects or clusters, namely the distance measure and the linkage method. Linkage method is used to measure the proximity between two clusters which when it merges, the number of objects is more than 2. Distance measure is used to measure that the proximity between two objects or cluster which contains only two objects if it's merged. Output of AHC is a dendrogram, which is a hierarchy diagram that summarizes the process of clustering. For linkage method, we use the word linkage. Carvalho's research recommends to use word linkage on geospatial data because it results clusters with similar sizes while the others result very different sizes. Since we work on geospatial data, we use word linkage by using word linkage, the cluster form is a cluster that has a minimum sum of square value. Distance measure. For the distance measure, we use Euclidean distance. We use the basic and most common distance measure for word linkage, Euclidean distance. Here's the Euclidean distance formula. The basic steps of AHC are: first, compute the proximity matrix and then let each data point to be a cluster. Next, merge the two closest clusters and update the proximity matrix and repeat it until only a single cluster remains. With a dendrogram, determine where to cut the hierarchical tree into cluster. This creates a partition of the data. Next, we have matching problem models. Equation 3 represents the objective function of matching problem, which maximizes the sum of weight. XDR is a variable which equals to 1 if the match is an optimum match and 0 otherwise. WDR denotes weight, that is the contribution of pairing driver D and rider R. Equation 4 ensures the riders pair only to one optimal driver. Equation 5 ensures the driver pair only to one optimal rider. Equation 6 is a binary decision. Since the goal is to maximize the total distance savings, then WDR is substituted by distance savings. Distance savings occur when the total mileage of ride-sharing trip is less than the total mileage of individual trip. Next, we're going to discuss how to decide the match of ride-sharing trip. The match for ride-sharing trip. First of all, we will make pairs of the driver and rider. Then we call the pair as a possible match. So we have a set of possible match. After that, if a possible match satisfies time feasible constraint and its distance saving is not less than 0, then it becomes a feasible match. Then we use Hungarian algorithm to get a set of optimum match, which result the maximum total distance savings. By applying AHC, a match of driver D and rider R is a possible match if their origin in one cluster and their destination in one cluster. The goal of using this criterion is to reduce computation of driver-rider combination that will be optimized. Also, the criteria of possible match assure the proximity of both drivers and riders' origin and destination. Here's the possible match algorithm. Note that this algorithm only works on two clusters. This is the time feasible constraint. The constraints are the delta TD and delta TR must not less than 0. The final step is to select the optimum match. Hungarian algorithm is used on this step to generate the set of optimum match, which consists of matches that results the maximum total distance savings. Please note that before we run Hungarian algorithm to determine driver-rider match who ready to do ride-sharing trip, we should eliminate match invisible match set that have distance savings less than 0. Here's our data set for this experiment, we have data set that contains 120 objects. The variable consists of longitude and latitude. We split the object into four parts: driver's origin and destination, also rider's origin and destination. On this research, we use Euclidean distance to calculate the travel distance. For the travel time, we get it by multiplying the travel distance with a constant number and 60 seconds. The constant number converts the Euclidean distance to kilometer. Here's the illustration of the period. The number of time periods we use is 3 time periods. Driver and riders whose time announcement at 7 hours 1 second until 7 hours 50 seconds are on the first time period. Meanwhile, the drivers and rider whose time announcement in 50 seconds after the first time period are on the second time period, and so on. This is the result summarized. As the result, we get the same total number of optimum match and the same driver-rider match by using and without using AHC method. Note that with using AHC method, the number of possible match for each period is less than the result of without using AHC. It means AHC is better to use because its ability to reduce the number of driver-rider combination which will be optimized, since AHC only combine the participants which their origin and destination is close to each other. On this experiment, we obtained the same number of optimum match with and without applying AHC. At the process, by applying AHC, we can reduce the number of possible match so that the total calculation of the driver-rider match that will be optimized is less. These are the references we use. That's all. Thank you.
Thanks for presentation. Is there any question for Ms. Anggun? Is there any question for Ms. Anggun?
I have the question for Anggun.
Okay.
So I want to ask about, as you said in your presentation, you have only 2 clusters. Why do you use only 2 clusters? And what's the background of cutting the dendrogram? Thank you.
Okay, thanks for the good question, Miss Sabrina. All right. Actually, we don't have any special reason to have only 2 clusters. We could have 3, 4, 5, or more clusters. We choose to have only 2 clusters because it's the minimum number of clusters to split the data. Also, it's easier to write the program if you only have 2 clusters. Note that on this experiment, we focus on the effect of using agglomerative hierarchical clustering without considering the optimum number of the cluster. I think it's an interesting topic for further research. Yeah, that's all. I think it's a good answer for your question.
Okay, thank you for your answer, Miss Anggun.
Is there any other question for Ms. Anggun? Okay, I want to ask one question. In the conclusion, you say that the results of using AHC or without using AHC is same or equals. So what is the need of using that algorithm? Because I don't see you explain about the difference in maybe in computational time or something like that.
Okay, thanks for the question. When you use AHC on the program, you will reduce the combination of the
possible match. If you have 5 drivers and 5 riders, then if you do not use the AHC, you will get 25 combination of drivers and riders on the possible match, 25 possible match. Well, if you use AHC, maybe you will get less than 25 combination of driver riders. It affects on the calculation of the time feasibility and another constraint on the search of the searching on the feasible match. Yeah, that's my answer.
Okay. Usually we try to reduce maybe the search space or something like that you do in this paper. If the problem is very big, or for example, the number of driver is maybe 1,000 and the number of the passenger is so big, so we need to reduce it. But if the number of driver is small, I think we don't need to use that. But if your data set is larger, I think it is more interesting, I think.
Yeah, the problem is from the larger participant on the very short optimization time. So we need clustering to reduce the combination to calculation the constraint.
Okay, I think it is the end for Miss Anggur. Thanks for the presentation. We continue to the next presenter. The next presenter is Mr. Max Rizal, and the title of his paper is Non-Singular Matrix as Private Key on L-Kamal Crypto System. For Mr. Max Rizal, time is yours.
Okay, thanks Mr. Lutfi. Assalamualaikum warahmatullahi wabarakatuh. I start sharing my video. Is it clear? Is it here? Loud here or not?
Try to play it. I cannot hear the voice.
Okay.
I see the video, but I don't hear the voice. Maybe you can close the share screen first and then you share screen again.
Oh, okay. I try again. Is it okay, Mr. Mr. Lutfi?
I cannot hear the voice. Maybe we will play it for you. Shahrul, can you play the
Okay,
video?
okay. Okay, plan B.
I can help you.
Assalamualaikum warahmatullahi wabarakatuh.
Okay, let's play.
I will present the result of our research entitled Non-Singular Metric as Private Key on Elgamal Crypto System. My name is Mat Rizal. I am from Institute Science dan Business Atmaluhur, Pangkal Pinang, Bangka Belitung Province. The Elgamal crypto system is a public key crypto system using commutative algebra. This crypto system has been improved and has been combined with other crypto systems. The purple crypto system improvement from the Elgamal crypto system is vulnerable in the encryption process. For this reason, experts developed the Elgamal crypto system using the concept of non-commutative algebra. So in this research, we change the commutative algebra to non-commutative algebra. Okay, scope of the problem, we limit our mathematical review to the topic of the Elgamal crypto system. In the previous research, we have this equation, the Elgamal formula, with public key and private key, with Y and G is a matrix. In our works, the equation is same. We use private key is matrix is G. So our contribution is change the private key X integers to the matrix G. Basic method of this research, the first, we modified the key generating algorithm. We replace the integer private key X into a matrix G. We change integer to the matrix. The second, we modified plaintext and encryption. We modified the encryption algorithm on the message senders. The third step, modify the description. We modify the equation in the message recipient of message description. To validate the purpose theory, we have to prove it with algebra existing mathematical concept. Also, we use Mathematica 5.0 software to simulate the three states above. Next, we have result and discussion. The first, we have advantage of the matrix as a private key in the purpose Elgamal crypto system. First, in this equation with G element of general linear group in field Fp is all of set non-empty set of matrix with non-zero determinant. This is a general linear group. We choose it for private key. So the power or the strength of the proposed Elgamal crypto system lies in complexity of factoring the matrix G. So if we have y equals then g metric power 100 modulo 11 with entry 7, 3, 10, 6, we will have trouble finding the private key G, because in algebra or in mathematics, root of matrix is not yet finding. So we have safety from attacker to mathematical attack. Second, we have advantage about brute force attack. Brute force attack is all possible key trying to hacker to attack this crypto system. Brute force attack on the proposed crypto system will be more difficult to work with because of the many possible trial and error in the matrix G. The proposed algorithmic crypto system can calculate by this equation. But in algorithmic crypto system and its variant, or in previous research, we only have P possible of brute force attack. The third, the proposed algorithmic crypto system can work on relatively small prime number. For example, we choose P is 11. In algorithmic crypto system, the hacker can attack by 11 attempt brute force attack. So hacker can try to input 0, 1, 2, 3 until 10. It's very easy to try. We work on the proposed algorithmic crypto system. We can choose P is 11 and we assume the matrix G with size 4 times 4 element of general linear group. We get many digits brute force attack experiment. We can compare it. 11 compare this many digit of brute force attack experiment. I think this more safety than algorithmic crypto system. The purpose algorithmic crypto system more safety. Okay, in purpose algorithmic crypto system, the algorithm start in message recipient. For example, we have Bob and Alice. Bob select G 3 times 2 matrix, and from G 4 times 4 matrix, its patterns. With O2 times 2 is the null matrix, and I is identity matrix. Next, Bob choose any X, and from Y 4 times 4. This is algorithmic equation. Next, Bob choose any S. In this step, we know Bob gets the private key G3 times 2 and the public key. Next, message sender, Alice chooses any key. Alice select H 2 times 2 and from H 4 times 4, which null matrix and identity matrix. Alice calculates T, H times Y times K. So Alice gets the private key and the public key. Next, message recipient Bob calculates P equals then S times T times G. This is step in key generating algorithm. In encryption, Alice calculates Q equals then H times P times M, with M is message or plain text. And she also calculates U equals then H times S times H. Note that H is different size. In the description, bar from X equals then U times Y times K times G, whereas G is private key. G is script. G only have in Bob. Next, Bob calculates the matrix M to rewrite the plain text with this equation. We have conclusion. The results show that we can modify the key-generating algorithm, encryption, and description algorithm so that the purpose system can work. Okay, this our reference. I think that's enough. That is a brief presentation of our research results. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Thanks for the presentation. Is there any question for Mr. Masriza? From the presenter? Is there any question in Google Form, Shahrul?
Nothing, but nothing.
Yeah, I will ask one question. In conclusion, you say that Elgamal system still working on matrix of specific size, and then you also show that you can modify the key generating algorithms, encryption and description, so that the proposed system can work. My question is there any other researchers that also have research in this in this study or in the area of study?
Okay, thanks Mr. Lutfi for your question. The Elgamal crypto system is in the previous study, Elgamal crypto system is generated by Elgamal and its variation, because this variation a lot of in prime number P, the private key still working in integers. So in our research, our change the integer private x to the matrix. The aim is to make many possible key two difficult hacker hack this plain text. So in computer science, algorithm crypto system and variation still study. I think this is our answer. Thanks.
Thanks for the answer. I think it will be more interesting if there are people who have many background in algebra. I think.
Yes.
I think almost all of us is. I think we all of us discuss about clustering or machine learning,
yes,
something like that.
The first,
Okay,
I
thanks.
hope I will find the people in algebra apply algebra, but also in this room I have new knowledge and idea about this before presenter. Good, thanks.
Okay, thanks, Mr. Max Rizal. We continue to the seventh presenter. The name of the presenter is Mr. Haryo Satyewo Purwarati, and the paper is Application of Mean-Shape Clustering to Optimize Matching Problems in Ride Sharing for Maximize the Total Number of Match. I think it is similar. It has a similar topic with Miss Indah and Miss Anggur. Okay, Mr. Purwarati, time is yours.
Okay. Thanks the time. Okay, I can share my video.
I have made you a cover, so
yes,
you can share. Please start your video.
wait. The voice.
I don't hear the voice.
The sound. The voice.
I cannot hear.
Wait.
Are other presenters can hear the voice?
Wait.
No.
I think we will play it for you. Maybe Shahrul, can you play the video?
Okay.
Yes. this section, I will present the paper about application of massive clustering to optimize matching problems in ride sharing for maximize the total number of match. Me, Haryo Sadewa, is author 1 in this paper, and this is our team. There are the outline. I will present introduction, literature review, model formulation, experimental result, and conclusion. Introduction. The massive population growth, resulting in an increase the number of movements and increasing the road user in the city. Population movements that occur generally include going to work, school, and other. This will require a government effort to improve road facilities and public transportation. Inadequate public transport service, where however what happens is the use public transportation is still not effective. Public transportation is still cannot provide comfort to passengers. Due to these factors, private vehicle users continue to grow. The growth in the use of private vehicles and vehicle volume increases not proportionally to road capacity, and there is infrastructure development resulting congestion. There are many solutions of congestion. Increase the number of public transportation flights, applying all the event, one-way lane, and ride sharing. One solution that will be discussed in this paper that can reduce the use of private vehicles and congestion is to use the ride-sharing system. Ride-sharing can increase the efficiency of urban transportation systems so that it can reduce congestion, fuel consumption, and air pollution. Ride-sharing, how to pair drivers and riders. Between the two. The first step before optimizing the matching problem on ride sharing is determining possible match pair. This is the illustration of possible match. The problem encountered in ride sharing is to get the optimal driver-rider pair, while the number of participants involved, the optimization time is very short. In this paper, clustering will be carried out an initial step before determining the possible match pairs. The clustering method that will be used for this paper is mean-shift clustering because there is no need for model assumptions at the initial stage of clustering. There is only one parameter used, namely bandwidth, which will determine the number of clusters automatically, so that it can make it easier to determine the number of clusters or grouping automatically. After the possible match are obtained from the clustering result, a driver and rider pair will be checked whether they are feasible or not. There is an illustration of feasible match. After finding a feasible match, the final step is to optimize the matching problem by using an objective function for maximize the number of match in the ride-sharing system. The mathematical model of the matching problem or ride-sharing is in the form of maximum weighted bipartite matching. Hopcroft algorithm will be used in this paper because the algorithm aims to find the maximum cardinality of the number of pairs that match according to the objective function to maximize the number of pairs that match to do ride sharing. Literature review. Next, literature review. Ride sharing and mean-shift clustering. Ride sharing. The ride sharing is a model transportation in which individual travelers share vehicle and travel costs with other travelers who have the same time and destination that are almost the same. The ride sharing system based on the type of implementation. First, organized and second, unorganized. Then massive clustering. Massive clustering including under the category of clustering algorithms that assign data points to group iteratively by shifting the points to mode. Mode is the highest density of data points in the region. The basic idea in massive clustering is to run an initialized mean shift loop at each data point, and then each mode defines one cluster with all points convergent to the same mode on the same cluster. Model formulation and model formulation. Assume A element D union R represent trip requests from drivers and riders or ride-sharing participants that consist driver D, element D, or rider R, element R are assumed to be null. The time announcement, time when the driver and rider is requested, is to A. The time window of A is A and KA, where EA is the latest time the participant can arrive at its destination LA, and soon to be now. And define delta TD, the formulation delta TD and delta TR is where.
Sorry, Mr. Shahrul, I think we can jump to the result section because I think the theory
is the ultimation time finished. If the pair of drivers and riders satisfy the following condition, delta TD null and that pair will be a feasible match and we will donate to a feasible match by this. Model formulation maximum. This is model formulation with WDR is 1 there, and this is the the objective function of matching problem which maximizes the sum of weight WDR of the matching pairs subject to this and this. Make sure that every driver D in the ride-sharing system serves exactly one rider, and make sure that each rider R on the ride-sharing system is served by exactly one driver, and this a binary discussion variable that is equal to 1 if the driver and rider is matched and 0 otherwise. And experimental result. This experimental result in 3 time periods with massive clustering, and this experimental result in 3 time periods with clustering. Conclusion: pairing a driver with a rider or a matching problem is a problem in the ride-sharing system. By using massive clustering, we'll make sure the driver-rider pairs that will be optimized are in a close proximity so that driver does not need to go too far to pick rider up. Then the matching problem is optimized by maximizing the number of pairs that match with the Hawcroft assignment algorithm. Based on the experimental result, get the same number of matches. If the number of participants involved in the system is very large but the optimization time is very short, we can conclude that with massive clustering will be more effective and efficient for the next step than without clustering, because clustering can also reduce to the total conversion of the driver-rider pair that will be optimized by reducing the possible match. Q&A. Thanks. In this section.
Thanks for the presentation. Is there any question for Mr. Haryo?
I wanna ask Mr. Haryo.
Yes.
Uh, Hello.
Hello.
Yes. Yes, you can ask.
Okay. Why did you choose mean safe clustering, and what is the advantage and disadvantage of that method?
Okay, thank you for your question, Filza. I chose massive clustering because massive clustering is built on the concept of kernel density estimation, and therefore the user doesn't need to select the cluster number. And advantage for the main safe is first, not need to make any model assumption. Then the user doesn't need to select the cluster number. And second, it can also model the complex clusters which have concave non-convex shape. And then there is no issue of local minima as like in k-means, and no problem generated from outliers. And this advantage of massive clustering. And this advantage of massive clustering first doesn't work well in case of high dimension, and then it cannot differentiate between meaningful and meaningless models. That is why I chose massive clustering and advantage and disadvantage.
Okay, thank you, Mr. Haryo, for your answer.
Okay, thank you. Your
Is there any other question for Mr. Hari?
I have a
Okay.
question.
Ms. Faisal, do you want to ask a question?
Yes.
Okay.
Okay, my name is Faisa. So I want to ask, what is the benefit by using ride-sharing system for participants, including the drivers and the riders? Thank you.
Okay, thanks for the question. The benefit of using ride sharing for general is reduce traffic congestion, and for the rider and ride, or the driver and the rider benefit. The first rider and driver don't have to make cash payment, and then the rider able to track where the driver is at any given moment, and then a rider notif as the driver gets close to where you are, and then the rider can contact the driver as needed. Then is more efficient for commuters, the rider and the drivers, and using ride sharing is more efficient because because the rider and driver uh, uh, can match the very close vehicles. That is a benefit of ride sharing for the rider and drivers overall.
Okay, thank you for the answer.
Yes, you are right.
Okay, I think before we continue to the next presenter, I want also ask you a question. Okay, from the three papers who study about ride sharing, I think the problem you use is too small because I think the biggest one is uh, 16 drivers and 17 riders. So I think it will be good if you can add more drivers and more riders. Uh, uh, because if the number of drivers and riders are bigger, then we can see the more advantages of using uh, the, the the method you use. And also, I think it will be better if you show the time you need or your program need to solve the problem. So if you use clustering, mean shift clustering, uh, how much the time do we need to solve it? And if we don't use the clustering, how much the time we need to do the clustering? Because if the problem is small and our computer is too good enough, and the number of driver and rider is small, we will not see any difference in computational time. And uh, I think you need to collect more data for your paper.
Okay. Okay, thank you, Mr. Lutfi.
Okay, I think it is not a question, but it is a suggestion for it. Okay, we will continue to the eighth presenter. The presenter is Sabrina Tiffany, and the title is The Comparison Between Extreme Learning Machine and Artificial Neural Network Backpropagation for Predicting the Dengue Incidences Number in DKI Jakarta. For Ms. Sabrina Tiffany, time is yours.
Okay, thank you for your opportunities. So let me show the video first. Can you see this video?
Yes, I can see.
How about the voice of the video?
Yes.
Okay. Good morning, everyone. Today, I'm Sabrina Tiffany will present the paper with title The Comparison Between Extreme Learning Machine and Artificial Neural Network Backpropagation for Predicting the Dengue Incidence Number in DKI Jakarta. This presentation consists of 5 sections as follows. The first section is Introduction, which will begin with the information about the HF. So, what is the HF? The HF, or dengue hemorrhagic fever, is an endemic disease caused by dengue virus infection. This disease is transmitted to humans through the bite of an infected mosquito, especially Aedes aegypti and Aedes albopictus. The number of dengue incidents in 2020 for each province in Indonesia is illustrated by this picture. It can be seen in the picture. DKI Jakarta has the 6th highest dengue incidence number, which reached 4,227 cases. To optimize the prevention effort and handling dengue cases that has been done by government, it is necessary to predict dengue incidence in the future. Prediction process is usually related by machine learning method. One of method that is most frequently used to make a prediction is artificial neural network or ANN. ANN generally use the backpropagation algorithm in training process. Although ANNBP is mostly used in many applications, it still has some limitations, such as slow learning speed, the existence of local minima, and the inappropriate learning rate that can cause overtrain. To overcome all of these limitations, Wang proposed the Extreme Learning Machine Method or ELM method. There are two goals of this study, which can be seen in this slide. The second section is material and methods. This part will be started with the information about data that are used in the study. We use two types of data, namely daily weather data and daily cumulative dengue incidence number data. From 5 municipalities of DKI Jakarta, except Kepulauan Seribu, that are recorded from 6 January 2009 until 25 September 2017. The daily weather data is consisted by three variables include the cumulative rainfall, the average temperature, and the average humidity. These data are obtained from Meteorology, Climatology, and Geophysics Agency, while the daily cumulative dengue incidence data is obtained from the Epidemiological Surveillance section of DKI Jakarta Health Agency website. Next is discuss about Artificial Neural Network or ANN. ANN is a supervised learning method which is very popular. It has a self-learning ability that allows them to get a better result when more data is available. The structure of ANN generally consists of three parts, namely the input layer, the hidden layer, and the output layer. The number of hidden layers in ANN can be more than one. The training process of ANN is divided into two phases. The first is forward phase and the second is backward phase. Next is discuss about extreme learning machine or ELM. ELM is a feed-forward neural network method that only has one hidden layer. It is a supervised learning method that has a better generalization ability than ANNBP. ELM can do the training process rapidly because this method doesn't require an iterative process for training parameters. The structure of ALM consists the same part like the ANN structure, namely input layer, hidden layer, and the output layer. The difference between them is the number of hidden layers in ELM structure cannot be more than one. The algorithm of ELM are as follows. First, we assign randomly the input weight Wj and bias Bj, where j is the number of hidden nodes. Start from 1 until n cubes. The second step, we calculate the hidden layer output matrix that is symbolized with H capital. And the third step, we calculate the output weight beta. The entry of matrix H capital can be calculated by using the following formula, and the output weight beta can be calculated by using the following formula, where Y capital is the target value, which has form like this. Then will be discussed about the proposed method of the study. In the study, the data used contains missing values and noise in the daily weather data. We will preprocess data first by doing the data imputation using MEAN and cleaning the noise in daily weather data. After that, we will convert the daily data into the weekly data. The next step is determine time lag between the predictor variable and the weekly dengue incidence number. In this study, we will use weather variable and the previous number of dengue incidents as a predictive variable. Next, the weekly data will be normalized by using the min-max formula. After that, the dataset will be divided into training data and testing data with the composition of 90% training data and 10% testing data based on historical time series. Next, the LLN and ANNBP model will be constructed with the predictor variable act as input variable. and the danger incidence number acts as target variable. After we construct the model, we will do the implementation of ELM and ANNBP model. Then the performance of its model will be evaluated by using the RMS formula. And finally, we also compare the prediction result of ELM and ANNBP model. The third section is result and discussion. In this study, the structure of ELM and ANNBP models consists of one hidden layer, with which the optimum number of hidden nodes is chosen by trial and error, start from 5 until 50 hidden nodes. The best learning rate is assigned by trial. The best learning rate of ANNBP is assigned by trial and error, which there are 3 trials learning rate as follows. The input layer consists of 4 nodes and the output layer consists of 1 node. And the binary sigmoidal is used as activation function. The next is about the time lag analysis. Because by determining the biggest absolute value of autocorrelation and cross-correlation, we get the optimum time lag that can be seen in this table. By using the optimum time lag and the data proportion of 90% training data and 10% testing data, for North Jakarta, West Jakarta, Central Jakarta, and East Jakarta, it will be used 402 datasets as training data and 45 datasets as testing data. And for South Jakarta, it will be used 403 datasets as training data and 45 datasets as testing data. This table shows the best ALM model and ANNBP model for predicting the DG incidence number in DKI Jakarta based on RMSE testing value. In this table, there are numbers in bold that indicate the smallest RMSE testing value between ELM and ANNBP model. We can see that the best RMSE testing value is obtained when using ELM is smaller than the RMSE testing value which resulted from using ANNBP for 5 municipalities of DKI Jakarta. In this presentation, it will be only shown the plot of prediction result in South Jakarta. It can be seen that by using ELM, the prediction result approach the actual value, and for ANNBP, when predict with training data, it less able to learn the spikes data pattern, and when predict with testing data, the prediction value that is resulted exceeds the actual value. Next is conclusion. So the conclusion of this study is, first, based on the dataset used, ANNBP with learning rate 0.1 using 100 epoch has the better performance than the performance of ANNBP with the other learning rate. The second, based on the dataset used, LLN can yield the better danger incidence number prediction than that which was obtained by ANNBP. And the last conclusion is ELM can do the training process faster than that of ANNBP. The following is reference that is used in this presentation. That's all about my presentation. Thank you for your attention. Good morning.
Thanks for the presentation. Is there any question from other presenters?
I have a question.
Okay.
The question is, could you give me a simple explanation about the process of forward and backward phase in ANN on your research, please? Thank you.
Okay, thank you for your question, Ms. Anggun. So, as I say in the presentation, the training process of ANN is divided into 2 phases. The first phase is forward phase. I'm sorry, and the second phase is the backward phase. So, in the forward phase, we will calculate the activation function value of the hidden layer and output layer, and this value is useful for us to do the backward phase and continue to the backward phase. In the backward phase, we will update the weight parameter and also bias parameter using the common method, namely backpropagation method. And in the backpropagation method, the bias and weight parameter will be updated by using the gradient descent algorithm. So that's all the explanation about the the forward and backward phase.
Is there any other question for Ms. Stefani?
I have question for Sabrina.
Yes, please.
Yes, as you said in your presentation slide 18, you use the binary sigmoidal as your activation function. Why do you use it?
Okay, thank you for your question, Mr. Haryo. So why I choose to use the binary sigmoidal function as my activation function? So the reason is this function is differentiate in all point, and also the this function is commonly used as a activation function in artificial neural network. So that's the reason.
Okay, the last question from me. In this research, you compare two methods. The first one is ALM and the second one is ANNBP. You have explained that ALM only have one hidden layer, but ANNBP can have more than one hidden layer. So why you only use one hidden layer for your ANN?
Okay, thank you for your question. So why I only use the one hidden layer in my paper? So the reason is the form of my data. I mean the condition of my data. It's not complicated. So I'm only use the one hidden layer to reduce the running time.
Okay. How do you know that your data is not complicated?
My data is not contained with many features.
Oh, okay. But I think the performance of ANN is relies on the number of hidden layers and the number of nodes in each hidden layers. So if you only compare it with ANN with one hidden layer, I think you should try for adding more hidden layers, because if the data is not complicated, then it doesn't mean that we only need to use one hidden layer.
Okay, thank you for your suggestion.
Okay, that's all from presenter A. We will continue to the next presenter. The next presenter is Mr. Ikhwanul Kazi Dakwan, and the title of his paper is Level Alert Classification of Dengue Hemorrhagic Fever Cases in DKI Jakarta with the implementation of the random forest algorithm. For Mr. Zakwan, time is yours.
Mr. Lutfi, can you help me for the video?
Okay. Shahrul, can you? Play the video.
Okay.
Video. Okay.
Hello, good head for those of you who are watching this video. Let me introduce myself. My name is
I cannot see the video.
The results of the research that has been done with my lectures entitled Level Earth Classification of Dengue Hemorrhagic Fever Cases in DKI Jakarta with the implementation of the random forest algorithm. First, we will discuss about dengue hemorrhagic fever. Dengue hemorrhagic fever is an infection caused by the dengue virus, which is transmitted through infected Aedes aegypti mosquitoes. The existence of the dengue hemorrhagic fever due to three things. First is humans, second is mosquitoes as transmissions, and most importantly, the dengue virus. One method to measure dengue hemorrhagic fever cases in the population is the incidence rate. Incidence rate is the number of new cases of disease from a population at risk over a period of time. The equation for incidence rate can be seen as in the display screen. In DKI Jakarta, BMKG uses monthly incidence rate to form the basis for categorizing the level of alertness for dengue hemorrhagic fever cases for each district, which is categorized into three categories: safe, moderately safe, and unsafe. Weather can affect cases of dengue hemorrhagic fever. Rainfall, temperature, and humidity are the climatic factors that influence dengue hemorrhagic fever cases the most. Why do these three factors affect the dengue hemorrhagic fever? First, heavy rainfall will increase the number of breeding places for mosquitoes to breed. Second, the average optimum temperature for mosquitoes growth is 25 to 35 degrees Celsius, and the Aedes aegypti mosquitoes can survive for low temperatures. Humidity of more than 60% extends the life of Aedes aegypti mosquitoes and makes mosquitoes breeding more likely. The data that will be used in this research is daily data from rainfall, temperature, humidity, and dengue hemorrhagic fever. Dengue hemorrhagic fever incidents in several districts in DKI Jakarta, except for Kepulauan Seribu. It means only West Jakarta, East Jakarta, South Jakarta, North Jakarta, and Central Jakarta. That was obtained from meteorological, climatological, and geophysical agency, and we can call BMKG, and DKI Jakarta Health Office, and we can call Dinas Kesehatan DKI Jakarta. The data displayed at this time is the data has been pre-processed. The data was checked for missing value, then imputation was carried out with the average value. And then the data is converted into weekly data, as we can see on the slide. In this research, we use a random forest algorithm. Random forest is assembly learning method from decision tree proposed Riemann. Random forest algorithm is a supervised learning, and the process of random forest algorithm is first, choose and bootstrap sample from every data sets, and second, for each bootstrap sample, build a decision tree with modification on each node, and instead of choosing the best parameter among all predictors, attempt random sampling on M from predictors and choose the best parameter from each variable. And the last, predict a new dataset by joining N decision tree. For a classification problem, majority vote will be used. The method of measuring the level of accuracy from the result of the classification of the model will use confusion matrix. The confusion matrix pays attention to the classification result in the true positive, false positive, false negative, true negative categorized. The equation for calculating the accuracy of model is shown on the slide. This is the flowchart for our research. This table shows the correlation value at the specific time like for each variable with the incidence variable. Example, temperature with incidence, rainfall with incidence, humidity with incidence, and incidence with incidence. The yellow label shows the selected time lag value. In this table for each Jakarta, the time lag selected for temperature is 11, rainfall 10, humidity 8, and incidence 1. This is for Central Jakarta. This is for South Jakarta. This is for West Jakarta. And then this is for North Jakarta. So that it can be summarized for each selected time lags as shown on the slide. The parameter to be simulated is the n semester parameter or the number of tree builds. To validate the value to be selected from the simulation result using training data, the base parameter selection will be based on the lowest out-of-band error rate value. The model for each district has been built using training data, and the n semester parameter will be evaluated using confusion matrix to see the accuracy of the model in specifying the level of alertness for dengue hemorrhagic fever cases for each district in DKI Jakarta against testing data. The results of confusion matrix evaluation for each model can be seen on the slide. From the confusion matrix, the accuracy value for each model can be calculated so that it can be summarized in the table that is visible on the slide. From the analysis and result, it can be concluded that that the classification of the alertness level for dengue hemorrhagic fever cases by implementing the random forest algorithm provides an accuracy value for each district in DKI Jakarta. There are the accuracy value for each district. The results of this accuracy are obtained with the parameter the time lag value. This research can only predict the level of alertness in the next week because almost all models require incident data from the previous weeks. However, for the North Jakarta model, it uses incident data from the previous 2 weeks so that it can predict predict the next 2 weeks. This is my last slide, and thank you. Hello, good head for those.
Thanks. Thanks for the presentation. Is there any question from other presenter? For Mr. Ikhwanul?
I want to ask Mr. Ikhwano.
Okay, please.
Okay. Thank you for your presentation, Mr. Ikhwano. I want to ask about what is the benefit of this research for the stakeholder at Jakarta?
Oh, okay. Thank you, Ms. Filza Zabarina, for the question. I will answer question. And my answer is one of the benefits of this research is to provide early detection related to future dengue hemorrhagic fever cases, not only based on the not only based of number of incident, but we can provide with the number of incident and weather condition. And this research can be used by the world society to be aware, and the government set in providing policies or action to solve dengue hemorrhagic fever cases. Thank you.
Okay, thank you for your answer, Mr. Ikhwanul.
Okay.
Is there any other question for Mr. Ihwanu?
I want to ask questions.
Okay, please.
Okay, for Mr. Ikhwanul, what are the parameters that you use in random forest and how do you set the value of those parameters? And also, what is your suggestion for the future research based on your research? That's it. Thank you.
Mr. Gina, can you repeat the first question and the second question? It's too fast. Can you repeat again?
Oh, I repeat the question.
Can you repeat the question?
Okay. I want, is my voice clear?
Yes, yes.
Okay, I want to ask about the parameters in random forest. What are the parameters that you use and how do you set the value of those parameters? Is there a method or what? And what is your recommendation for the future research based on your research? Thank you.
Oh, okay. This is about parameters, and the random forest have two parameters, and estimators and max filters. Okay, for the first, the max filters parameter, there are two ways to determine the value. Either using the number of features that are routed or to log amount of features. Because we only use 4 features, the root from 4 is 2 and 2 log 4 is 2. The result is same, so that for max features, the parameter that I choose is 2 for each district in every model. And the second, for the n estimation parameter, it depends on the lowest value of out-of-bag error. Out-of-bag error can be calculated by the error rate of the model towards the data that is not included in the subsamples from bootstrapping. That is why we call it out-of-bag error rate, and it is for choosing the best parameter for n estimators. And for the second question is interesting question for recommendation for next research. Because in this research I only can predict next weeks, only 1 weeks. Maybe for the future research can use a like time more than 1 or 2 maybe. Uh, Hence, the model can predict 2 weeks or more. Thank you, Mr. Valery.
Okay, thanks for the presentation. Okay, I'm sorry because in front of my house there is a mosque, and maybe you will hear voice of salawat. So we will continue to the last presentation. Actually, it is from me. Can you see my presentation?
Yes, I can.
Okay, good afternoon everyone. This is my paper. The title of my paper is A Genetic Algorithm for Solving Large-Scale Global Optimization Problems. I'm the first author in this paper, and there are other 5 authors, and all of us come from Department of Mathematics of Institute of Technology School of November. This is the outline of my presentation. The first one is introduction. Large-scale global optimization or LSGO problems are global optimization problem with dimension higher than or equal to 1000. So we need to get optimized or optimum solution for a function which have more than 1000 variables or dimension. Currently, there are two important challenges in solving the LSGO problems. The first is the search space for the LSGO problems grow exponentially as the problem dimensions increase. Another major challenge is that the LSGO problems cannot be solved effectively using traditional mathematical optimization algorithms. Evolutionary algorithms are more widely used to solve this problem. It is because evolutionary algorithms are easier to use and can find fairly good solutions in a relatively short period of time. There are several studies in the literature that have tried using evolutionary algorithms to solve large-scale global optimization with up to 10,000 variables. In this research, we will propose a genetic algorithm for optimizing functions with many variables, up to 100,000 variables. The proposed algorithm must be fast so that it can be used to achieve all these variables in a reasonable amount of time. The next section is proposed genetic algorithm. So this one is the chromosome we use in our research. So if the function has d variables, then the solution or the chromosome are d-dimensional array like this. And in our population, we use 100 chromosomes. And for the selection, before we do the crossover, we use random selection. We choose 5 candidates, and then from the 5 we get, we choose the best one to crossover. This one is step for crossover. So if we have X is the first parent, and Y is the second parent, and Z is the child, then for every index in Z, for example, Zi, we will choose from Xi, Yi, or the mean from Xi and Ai, and we choose it until we get the best option. And this one is the step for mutation. So after we get the result from crossover, we do a mutation. So we will get W, and for every I in W, we choose from these 3 options, where epsilon I is chosen from this range values. And after that, we use elitism replacement with filtration for choosing the best 100 chromosomes for next generation, and the maximum number of generations in the genetic algorithm is 10,000. This is the step for our proposed genetic algorithm. And then this is the idea we use for dealing with many variables. For example, if the function we want to solve can be written as a sum like this. I'm sorry, this is I equals 1 to D. Then if we obtain new solution X axel is by replace X, Y with A, then the fitness value or the function value of the X axis is can be calculated by this equation. This is the test function we use in our research. So we use 5 different functions. The first one is pair function, the second one is Somers-Stiglitz, and then quintic function, and then step function. And the last one is Alpin function. This is the definition of the function. And the number of D, or number of variables or dimensions, is 10 to 100,000. And for each index, for each xi, the domain is from -10 to 10, and the global minimum is 0 for all functions. This is the result of our research. So for sphere function with 10 variables, then the function value we found by the GA is like this, you can see. And because we do not compare it with the other algorithm, because almost all of other paper just use 1,000 or maybe 10,000 number of variables. So we don't compare it with other algorithm. And for step function, you can see that we can find all optimal solution, because in step function there are many maximum points, and our algorithm can find all of its possibility easily. And then this is the time needed for our genetic algorithm to solve the sphere function. So it seems to be linear, and after we calculating the time, we have this conclusion. So if the number of variables is increased by 10 times, then the time we need to solve the problem is 8.2 times larger. And this is the best value, the best function value from the first 10 generation of our genetic algorithm. So the first graph A is for sphere function, this one is for Somers-Stiglitz function, C is for Filtri function, D is for step function, and E is for Alpin function. And all the graphs we show here have 100,000 variables. So you can see from this graph that our proposed genetic algorithm can find really good solution in very short generation. So this graph we only show the first 10 generations, but almost all of them are close to zero. Zero is the optimum value. And this is the code we use for this research. You can access it from my GitHub. You can access it freely. And conclusion and future works. In this research, we propose a genetic algorithm that can be used to solve large-scale global optimization problems. We also propose a simple approach to make the genetic algorithm run faster. From the results, the proposed algorithm can find a fairly good solution in fairly short time. For the future, the algorithm that has been proposed in this research can be redeveloped in order to solve other problems, especially for non-separable problems. We can also combine it with other heuristic algorithms so that its capabilities can be increased. However, in the development, the runtime must be considered carefully so that the proposed algorithm can be used by many people. And the last one is, this is our references. And thanks for your attention. Okay, is there any question for me? Is there any question for me? Maybe one presenter for improving my result.
I have the question.
Okay, please.
So, as you said in your presentation before, I see you decide to use the domain of function -10 until 10. Is there any reason?
Actually, there is no any reason, but if you see other people, they use smaller domain, such as from only -1 to 1. So I try to use the larger domain. So and we can see that is my algorithm can find with larger domain.
Okay, thank you for your answer.
Is there any other question? Okay, I think it will be the end of our parallel session in this day, this ICoMPAC 2020. And because we don't move to another Zoom anymore, so this will be the last Zoom we join in this ICoMPAC. So maybe you can turn on your video and I will take your pictures. Wait a minute. Okay, I will take a picture of you. 1, 2, 3. Wait, I set it. Okay, thanks for your attendance in this international conference. Before we leave our meeting, maybe do you have any question for ICoMPAC community? Is there any question? Maybe you want to ask about something before we end this meeting?
No, I haven't.
Okay. The certificate of this ICoMPAC will be announced in WhatsApp group. So you need to wait until we give you any information for the certificate. We will announce it in our group, ICoMPAC 2020 presenters in WhatsApp group. Okay, thank you very much for your attendance in this international conference. I hope we can meet again maybe next year or sometime, and we can discuss again about research and anything else. That's all for me. Shahrul, do you want to say something?
Nothing, Mbak.
Okay, if there is no other talk, I will end this session. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
wabarakatuh. Thank you.
Okay, I will end this Zoom meeting.